Hello Algebra 1 students, this is Mr. Wilsey, and in this video we're going to be studying the topic of conversion factors. So take down notes with me, as always, notes on paper. Let me start you off with a problem. Let's say that you find a snake in your backyard. That is indeed a problem, is it not? And this snake is 36 inches long. And a friend asks you, 36 inches, I don't know, is that a lot? It seems like a lot, maybe. Could you put it a different way for me? Could you tell me maybe how many feet long the snake is? Okay, 36 inches is how many feet long? Now, I'm sure that you can do this problem in your head, or if not in your head, at least you might have to reach for a calculator, but you should be able to see immediately that 36 inches is the same thing as 3 feet. Now in this video what I want to do is I want to analyze and break down what it is inside your brain that allows you to go from 36 inches to 3 feet. Because if you can figure out what your brain is doing in order to do this conversion in your head, then we can apply that same process to more difficult, challenging, and more interesting examples of converting units. So let's see what your brain did. The first thing your brain had to do in order to do this conversion is it had to access this piece of information. 1 foot equals 12 inches. This is a fact that at least everyone in the United States is well aware of. 1 foot equals 12 inches. Now this piece of information is called a conversion factor, and it is a conversion factor that you need to have memorized. So this is the first thing that your brain had to do. The second thing that your brain had to do is it had to take 36 and divide it by 12 in order to get 3. But the question is, how in the world did your brain know to divide by 12? Why not add 12? Why not multiply by 12? Or why not subtract 12? How did it know to combine these two numbers in this particular way to get the result? Well, in order to answer that question, let's take a quick detour over here. Let's say if I had something like this. 3 times 2 divided by 3. What is this equal to? Well, one thing you might do is simply use order of operations, do 3 times 2 on the top to get 6, divided by 3, so it would be pretty clear that this is equal to 2. Something else that you could have done, though, is you could have realized that because there's a number, 3, that appears on the top and the bottom of a fraction, and because the operation joining the things on the top is multiplication, then a shortcut that you could have taken is simply canceled out the 3 on the top and the bottom, leaving you with 2, which is of course the correct way to simplify this expression. So if we can do it with numbers, can we do it with symbols like letters? Well, sure we can. What about x times y divided by y times z? How do we simplify this expression? Well, the operation on top is multiplication, operation on bottom is multiplication, and there is a y that appears on top and on bottom, so that means that we can simply cancel out the y's, leaving us with x on top divided by z. So x over z is the simplest way to write this expression. Okay, so you're kind of getting the drift here. Let's try a little bit more of a challenging example. What about a times b times c times d, all divided by c times a times d times e? I know, this is getting like ridiculous, right? We're starting to write a book with all these letters. Well, how do we simplify this expression? Well, let's see. Everything on top is joined with multiplication. Everything on bottom is joined by multiplication. Now, let's see if we can spot things that appear on the top and on the bottom. Try to cancel those out. Let's see. We have an A on top and on bottom. We have a D on top and a D on bottom. We have a C on top and a C on bottom. This leaves us with B on top divided by E on bottom. Okay? Not too bad, right? Well, if we can do it with letters, can we do it with units? And what exactly do I mean by units? Well, units are, for example, inches, or feet, or hours, minutes, miles, etc. These are all units of measurement. And just like letters, or just like numbers, if you see them appearing in a division/multiplication problem like this, they can cancel out. So in this case, if I have hours times minutes divided by hours, well, we can simplify this. Hours on top, hours on bottom, leaving us with minutes. Okay, let's try one more example of this. What happens if we have miles times feet times hours times minutes? Again, you're writing this down with me. Hours times miles, pause the video if you need to get your paper, times minutes times seconds. Whew, this looks like a nightmare, right? But no, it's the same exact concept that we have been looking at. Miles on top, miles on bottom, minutes on top, minutes on bottom, let's see, hours and hours, leaving us with feet over seconds. Now, what in the world does this have to do with our original problem, with our snake? Well, watch this. 36 inches. Now, we're going to take 36 inches and we're going to multiply it by something. Here's what we're going to multiply it by. 1. We're going to multiply it by 1. Isn't that exciting? What happens when you multiply something by 1? Well, it stays the same. So why in the world would we want to multiply by 1? Well, watch this. We're going to take our conversion factor, divide both sides by, let's say, 12 inches. Why in the world would we do that? Well, look at what this becomes. 1 foot over 12 inches equals, let's see, 12 inches divided by 12 inches. What in the world is that? Well, anything divided by itself is equal to, you guessed it, 1. So we could do this, or we could just as easily divide both sides of this equation by 1 foot. So in this case, the equation that we would get would be 1 equals 12 inches divided by 1 foot. Now you're probably thinking that Mr. Wilsey has completely lost his mind. Well, that may be true, but I hope that this is not evidence of that. Here's what we're going to do. This fraction is equal to 1, and so is this one. If we multiply 36 inches by one of these two fractions, then we won't change the essence of what 36 inches is, but we will be able to convert inches into what we want, which is feet. Let me show you how we're going to do that. 1 foot, because that's what we see right here, and we're going to divide by 12 inches. So this part right here is just equal to 1, like we found. But notice what it does for us. We have a unit on top and the same unit on bottom, so they cancel out. And this will leave us with foot, or because English is silly, feet, in the final simplified form down here. But there's one extra thing that these problems did not have. We now have 36 on top of the fraction, 12 on the bottom of the fraction, and this means we have to take 36, divide by 12, which is exactly what we did in our head. 36 divided by 12 is, of course, 3. Okay, so that seems like a lot of work to do something you could already do in your head. why in the world would we do it in this convoluted way? Well, let's look at a couple more problems and build up the difficulty so that you'll see why this method is the way that I prefer that you do conversion factor problems.